Hello everyone. So in this video I'll be explaining you about Boolean retrieval. So in this video you'll be coming across what do you mean by Boolean retrieval and the concepts which are associated with Boolean retrieval. So before knowing what is Boolean retrieval, let us know the terminologies which are present. So terminologies which are associated are document, corpus and relevance. These three terms you are supposed to know. So what do you mean by a document? So document is a unit of retrieval. So each document will have its own document ID. Corpus is a collection of documents, and relevance of documents are supposed to be found in this system. Now, user will have some information need, and user is going to put a query to a system, and term is going to be a unit of information. Now, for example, in this video, I'll be considering corpus as collection of Shakespeare play and document as an individual play. And now the query will be a combination of Boolean operators such as and, or not. So using these three operators, we'll be dealing with the Boolean retrieval. So unstructured data in the year 1620. So when Shakespeare was writing the plays, uh, means the drama, skit, and all those things, those contents were unstructured. They were not in the tabular format. So we are going to deal with the retrieval of few certain documents from the Shakespeare play using a few techniques. So in this video, I will be explaining you about two techniques, that is your inverted index technique, and before that I will be telling you about what is term document incidence matrix. So here you are able to see in the screen that which plays of Shakespeare contain the words Brutus and Caesar but not Calpurnia. So one could grep. So grep means this keyword grep means it is used for combining. So in retrieval, grep indicates combining all the relevant ones. So or retrieving, find it out and combine it. All of Shakespeare play for Brutus and Caesar, and then strip out lines containing Calpurnia. Now we have come across term document incidence matrix. So here in what we will do with this technique is, in the column side I'll be writing the name of the documents, and in the towards the row or towards the instance I'll be mentioning what words are involved in a document. So if this word contains in a particular document, I'll be writing it 1 or else 0. Now incidence vectors. So we will have a 0/1 vector for each and every term. 0 means that word is not present. 1 means the word is present. Now to answer query, take the vectors of Brutus, Caesar and Calpurnia. So Brutus, if we take his one, if we combine that in the form of a vector, as you are able to see in the screen, we will be getting 1 1 0 1 0 0. And now for Caesar, we will be getting 1 1 0 1 1 1, and Calpurnia you will be getting 0 1 0 0 0 0. Okay, so if you combine, if you perform bitwise and for complementing Calpurnia, and if you perform the bitwise and operation, you will be getting 1 0 0 1 0 0 as the answer. Okay, so I'll be explaining, for example, if this Antony is present in the document Antony and Cleopatra, you will be writing it 1, or else you will be writing it 0. For example, this word Calpurnia is not present in the document named Antony and Cleopatra, so it is written 0. Like that you are able to see 1 if play contains a word, 0 otherwise. See Brutus and Caesar but not Calpurnia. So here also when we are dealing with the incidence vectors, we complemented Calpurnia and we did the bitwise AND operation. Now bigger collections. Let us consider n equal to 1 million documents. In the previous example, we came across hardly 6 to 7 documents. If we come across 1 million documents, each with about 1000 words. So average it for one word, it might take around 6 bytes. So 6 bytes per word, including spaces, means it is going to take 6 GB. Say there are 500,000 distinct terms. So 500,000 distinct terms and 1 million documents, I can't build a matrix because it is going to have more than 1 billion ones. Matrix is extremely sparse. Like 500k into 1 m matrix means has half a trillion zeros and ones. like that. So we only record the one positions. So to deal with this such position, instead of noting both zeros and ones, we will only consider where that number one is written. So that technique is your inverted index technique. So it is the improvised version of your term document incidence matrix. So for example, I will be taking for each term T, we must store a list of all documents that contain the term T. For example, this Brutus, I'll be having 1,000 documents. So out of those 1,000 documents, in which document that word is present, so that document number I'll be writing in the form of a vector. So for example, Brutus is present in document number 1, 2, 4, 11, 31, 45, 173, 174, and so on. Now we need variable size posting list. So the words which are present in the left side are dictionary and the words which are present in the right side are the posting list. And now the postings are sorted by document ID. So on disk, a continuous run of postings is normal and best. In memory, it can be used like a linked list or variable length array. Now, how to construct this inverted index? So we came across that for considering a term T, we will be listing in which document number that word is present. I'll be writing that in the form of a vector. So how to construct this? So we will be having a set of documents to be indexed. So those documents will be converted into small indivisible tokens, and now tokens, it will be sent to the token stream, and we will be dealing with the linguistic modules, and where we will be modifying the existing tokens, and then we will index. For example, if you are able to see at the right side, friends, Romans, countrymen. So friends, Romans, countrymen, it is a one sentence. So I will be splitting it into three. So friends, Romans, countrymen. Now friends, remove yes, means remove the plural form of it. You will be getting only the singular one. And then for that you write the inverted index. Now, initial stages of text processing, it will be tokenization, normalization, stemming, and stop words. So, tokenization means cutting character sequences into word tokens. Normalization means mapping text and query term to the same form. For example, we don't know what user, if any user, he might give the query in a different form. You are able to see in this example, we usually consider u.s.a, but USA without giving any dots is also the same as u.s.a. So both are basically same. So this is where what do you mean by normalization? Stemming means we are finding the root word of any given word. Stop word means it indicates your articles, prepositions, and common words. Those are basically common words which you come across any document. Now, here you are able to see index steps. Now, token sequence. I, document ID 1, did 1, enact 1, Julius 1, Caesar 1, I 1. Like that, I will be writing in individually for each and every word, and in which document it is present. Since each document will have its own ID, so I will be mentioning that ID. Modified token, comma, document pairs. Now, sort it by the terms and then by document ID. So this is the core indexing step. First you need to sort it by the terms, okay, and then by the document ID. Okay, so now you are able to see term document frequency and posting list. So multiple term entries in a single document are merged, split into dictionary and postings. Document frequency information is also added. Now, for a practical IR system handling a huge corpus, the dictionary will be stored in the memory, postings will be stored in the disk. Okay, but retrieving from the disk, it will take time. Means retrieving only those posting lists that are needed to answer a query. So that is the one of the challenge. So now we will come across with query processing with an inverted index. So how do we process a query? Okay, now consider the query which is given by a user, Brutus and Caesar. Now locate Brutus in the dictionary, retrieve its postings. Locate Caesar in the dictionary, retrieve its postings. And now merge it using the merge algorithm. So I'll be explaining the merge algorithm. So here, this the first posting list indicates the document ID in which Brutus is present, and the second indicates in which document ID the word Caesar is present. Now, the merge algorithm. So walk through the two posting lists simultaneously in time linear in the total number of posting entries. Now, if the list lengths are x and y, then the merge will take big O of x plus y operation. Now we came across the merge algorithm. So intersect P1 comma P2, where P1 comma P2 indicates the posting list. Now answer initially I'll be keeping it as null. So while P1 not equal to nil and P2 not equal to nil, means where I'll be having document IDs even in P1 and P2, do if doc ID of P1 equal to doc ID of P2. Means consider some particular at index of ID P1 and P2, both compare it. If both are equal, then add it. Or else, if document ID of P1 is less than P2, then P1 shift both the pointers to the next position. For example, you are able to see here 2, 1. Both are not same. Shift it. Shift only this one. Okay. If doc ID of P1 is less than P2, so that was the condition which was mentioned here. So if doc ID of P1 is less than P2, then P1 will be shifted next and then P2. Okay, but here doc ID of P2 is less than P1. So P2 should be shifted and then it must be compared. So 2 and 2 it is same. I'll be retrieving it too. And then I will go to the next like that. Now Boolean queries. So Boolean retrieval model is being able to ask a query that is a Boolean expansion. Boolean queries are the queries which deals with Boolean operations. That is your and, or, and not operation. Now many search systems which they have built still use Boolean operations only. For example, your library catalog, Mac OS, email, etc. For example, here they have given a company like a Westlaw. So it is the largest commercial paying subscribers legal search service. So it started from 1975, ranking added 1992. It is a new federated search. So tens of terabytes of data are there. So as of now, around 700,000 users. Majority of users still will use Boolean query only. So what is here, they have given a query and they have converted into some form. So what is the statute of limitations in cases involving the Federal Tort Claims Act? So limit exclamatory mark slash 3 statute action slash s federal slash 2 tort slash 3 claim. Like they have converted into some form and they are giving the query and they'll be fetching it. Now query optimization. So what is the best order for query processing? So consider a query that is an AND of n terms. So for each of n terms, get its posting and perform the AND operation. AND operation means that document ID particular one should be present in both the lists. So that is what you mean by AND operation. So this acts as a solution for your inverted index. Now query optimization example, start with the smallest set and then keep cutting further. Now Brutus Caesar. Okay. See, Calpurnia, execute the query as Calpurnia and Brutus and Caesar. Means first you deal with Calpurnia and Brutus and then come for Caesar. Like that. So Calpurnia and Brutus, if you combine, you'll get it 0. Because there is no, sorry, Calpurnia and Brutus you'll be getting 16 as 1. And then 16 and come across with Caesar, you'll be getting only 16 only. Like consider Calpurnia and Brutus. So in these two, which document ID is common? So 16 is common in both. So write 16 here and Caesar. So Caesar also it consists only 16. So 16 and 16 you will be getting 16 as the answer. Now this is the more general optimization. So that is what I explained, like how I gave the explanation of this algorithm. So intersect T1 so on till Tn. Now terms sort by increasing frequency. Now result means it is converted into posting list. Terms will contain rest of the terms. So unless and until the terms and the result will be nil. Result means perform the intersection between these two document lists, and then terms include the terms which consist of other terms, and then result, return the result. So now this is the example for you. So they have given tangerine or trees and marmalade or skies and kaleidoscope or ice. So which two terms should we process first? So considering this as the frequency. So tangerine, the frequency is 46,653, or trees 3316812, marmalade 107913, skies 271658, kaleidoscope 87009, ice is 213312. So marmalade or skies, if I perform, then this it will give more frequency. So marmalade or skies should be performed first, and then kaleidoscope or ice, and then coming for tangerine or trees. So with this note, coming for your Google, uh, how does the Google use the Boolean model? So Google, it will use the default interpretation, like your consisting of a vector of terms, that is your w1, w2, w3, so on till wn. So perform the AND operation between each and every word. So w1 and w2 and w3 and so on till wn. Now cases where you get hits that do not contain one of the wi. So I indicates the particular index. One is your anchor text. Anchor text means the clickable text. Suppose you go to a web page and you will be able to see a blue hyperlink marked one. So if you click on that blue one, you will be redirected to a different website. So that is one case. That one hit can happen. And now page contains variants of WI, that is your morphology, spelling correction, synonym, long queries, boolean expressions, etc. Now simple boolean retrieval will return matching documents in no particular order. So now Google will rank the results, and then Google will rank the result set, and then they rank good hits higher than the bad hits. So when we come across these words, you should be able to know what is the meaning of good hit and bad hit. So hit means it is occurring in a document. So they rank good hits and then they will rank the bad hits. So with this note, I'll be ending the video. Thank you.